Hello everyone. Today we'll be discussing about harmonizing synchronous systems with NATS, CloudEvents and AsyncAPI. It's really great to see everyone here and to talk about these particular technologies. My name is Artur. I am a lead computer scientist at Adobe right now, and you can find me on the internet at these addresses. This is my Twitter link, the LinkedIn handle, and GitHub handle. So today we'll be talking about, this is the quick agenda. We'll have a quick introduction. We'll cover NATS, CloudEvents, and AsyncAPI. We'll also look into a demo. Hopefully we'll have time for that. And then we'll have the final takeaways. So building a synchronous system is quite difficult these days. It's a lot of work. And to build a good, resilient, and reliable system is really complicated. One of the reasons for that is that I can think of the synchronous systems as these highways that are always in flux, and everything is moving around, and without proper preparation and planning in mind, you will run into all sorts of issues. But compared to asynchronous systems, we can actually do better, and we can plan ahead of time and design our system to be resilient, reliable, and performant. In the title of the talk, I mentioned harmonizing. So I think it's worth looking at the dictionary definition of these terms. So harmony is a state where different elements come together seamlessly, creating a sense of peace and unity. This is actually coming from the music industry, and it's a very old word. And harmonizing, on the other hand, means blending different parts to create a cohesive and pleasing whole. And what is really interesting in the second definition is that the pleasing part. I do think that as engineers, we tend to forget that when we build something, in order for it to be understandable, it's not, we shouldn't just strive to be so it's clear, but we also should make sure that it has this kind of non-functional requirements like being beautiful, elegant, and pleasing. As humans, we use abstractions and metaphors to try to explain complex things. So I was thinking that for this presentation, we will use the just-in-time delivery metaphor from the supply chain management. And what I was trying to depict in this particular picture is that we have the map of the world, we have the routes, and we have the boxes moving around. And just-in-time delivery is a really good metaphor for messaging system, because if we delay something, things can break, and sometimes really bad things can happen. However, if everything is efficient, then everything is moving around pretty quickly, and everything reaches the destination just in time. So I think this is like a really good metaphor for asynchronous systems. So the stars of the show are NATS, CloudEvents, and AsyncAPI. If we look at the just-in-time delivery metaphor, then NATS would represent the transportation, and we can think of planes, trains, cars, trucks, things that are moving data around. CloudEvents is the packaging. It's just the boxes that we normally put all the goods in, and they are standardized, and they have the necessary data like routing and labels. And AsyncAPI, and we can think of it as the map, the route description, or the route planner, which allows us to efficiently move data from point A to point B. First, we'll look a little bit at NATS. NATS is a pub/sub messaging system. It's a pretty old project. It has been started in 2011, and I would like to think of NATS as a system that provides these building blocks to build more sophisticated distributed systems on top of it. It's kind of like having these axioms from Euclid elements. Like we have 5 axioms that you can build a whole 3D geometry on top of it. Or for those that are more into computer science, There is a really nice essay by Paul Graham where he talks about the roots of Lisp, and he shows that the whole Lisp language is comprised of 7 primitives. And NATS is kind of this, NATS have these really nice primitives that you can build everything on top of that. And it's not just pub sub, you can have request reprise and other things on top of that, but I'll cover it a little bit later. And in the just-in-time delivery metaphor, I would like to think of NATS as this high-speed train that can deliver data efficiently from point A to point B, which is really lightweight, slim, fast, efficient. As I mentioned, the NATS is the transportation. It provides low latency. It's really high performant. Supports multiple messaging patterns, as I mentioned, pub, sub, request, reply, core, queue, streaming, and so on. It comes with high availability and built-in resilience. Also, it's really important to mention that it's a CNCF project. It's currently in incubating phase. Most probably, it will graduate soon. Next on the list, we have the cloud events. The cloud event is a very tiny specification. It's also part of CNCF. It actually derived from the serverless work group, and it focuses on just providing the essential metadata for routing, transforming, and validating events. And in the context of just-in-time delivery, I would like to think of cloud events as the boxes that we're using to package the goods. Boxes can have different shapes and sizes, but the most essential details like routing and labels are important to make sure that that the boxes reaches the destination. And so, just to reiterate, cloud events are the packaging mechanism. They are lightweight. They provide essential metadata. They really enhance interoperability. And what's really important is that cloud events has been created in collaboration with the big hyperscalers like AWS, Azure, Google Cloud, and others. Adobe is also part of this effort. It supports the various event-driven architecture, and not the least, it's protocol agnostic. You can send cloud events via HTTP, Kafka, NATS, whatever. It's actually the cloud events don't really care which protocol you use. And compared to NATS, cloud events is actually a graduated project, which is really, really cool, which means that it has enough adoption within the industry and you can use it safely. Okay, so I guess everyone guessed what it is. It's a jar of jam. And I was thinking that in our industry, we have a lot of acronyms, and I decided that we probably should have my own. So in terms of cloud events, we can say that we have GEM, which is GEM, and stands for just enough metadata. And why I think it's really cool to have GEM for cloud events is because it's really like that simple. The core specification of cloud events is like it requires only 4 fields: spec version, ID, source, and type, and that's about it. It has an extension mechanism, but for most of the things that we need for routing and sending data between systems, these details are usually more than enough. Finally, on the list, we have AsyncAPI. As I mentioned, you can think of AsyncAPI in the as this route description or the route planner. AsyncAPI itself is a specification. It's part of the Linux Foundation. It has been out for quite a while, and it tries to do like a heroic thing to document asynchronous and event-driven architectures and APIs compared to OpenAPI, which probably is more well-known. OpenAPI, on one hand, focuses on HTTP and REST APIs. AsyncAPI tries to be a little bit more ambitious. It tries to document asynchronous systems and asynchronous interactions. And here we have a lot of protocols, a lot of services, a lot of messaging system and things like that. We have the usual like enterprise thingies like Kafka, then we have NATS, RabbitMQ, the messaging and PubSub services from hyperscalers like Google PubSub, Azure SQS, AWS SQS, Azure Event Hub, and so on. AsyncAPI can help with all of this, but unfortunately, it's not well known. So I hope with this presentation, we may make sure that people are aware of this specification and can use it in their day-to-day work. Yeah, as I mentioned, in this picture, I try to depict that AsyncAPI is this like overarching specification that tries to cover different use cases, and that's why we have routes both over the ground and over the sea, which tries to like provide this metaphor that AsyncAPI can describe different interactions in a seamless manner. And to reiterate, we have AsyncAPI, which defines how messages are sent and received. It ensures consistency across services, which is really important. It provides clear documentation, which I think usually people underestimate. I have seen many services and many teams using just code or using wikis to document their interaction with asynchronous systems like Kafka or RabbitMQ. And it's really horrible. And apart from the spec itself, the AsyncAPI community has a lot of tools that can help you with simple things like authoring the AsyncAPI itself, the AsyncAPI specification, linting, validating, but it also has other integrations like code gen tools and many more. And as I already mentioned, it's part of the Linux Foundation, which means that there is interest from the industry, and it's not just some community-driven error. It actually has the backing of a foundation like Linux. All right, now that we are done with the theoretical part, let's see how we can use NATS Cloud Events and AsyncAPI in a fictional observability platform. So usually in the asynchronous or event-driven architectures, you see examples from e-commerce domain, and I decided to move a little bit away from the e-commerce and the usual order placed, order created payments and things like that. And I thought that we should focus a little bit on the operational side of things and talk a little bit about the observability, a fictional observability platform. So in an observability platform, you normally have the application that you try to monitor and collect metrics data from. You have the metrics agent. Then you have some kind of connectivity fabric, which in this particular case it's NATS, where you push the metrics. Then you have some aggregation service. In this particular case, we named it the data collection, where the data collection service actually tries to aggregate data, put it in a more efficient structure in the metrics database. And then we can have other services that consume this data and present it in some shape or form to the ops engineer or whatever person wants to look how the things are looking in production. Normally, you would use Grafana or something like that to visualize it in a nice dashboard. All right, so let's go and see how it all looks like. So this is the setup that we have. So we have the demo app. We have the metrics agent running. We have the data collection service. We have the reporting service. And this is our dashboard application, which is a very simple HTML page that is served by an HTTP server. Here we have our NATS server running. It uses Jetstream, so we could persist the details. And here we have some details around our data, where we push data in NATS. So in NATS, we can use NATS stream info, and we can check the metrics is the stream that we have created where we push the data. A stream is kind of similar to Kafka topic for those familiar with Kafka. And we have the NATS CLI, which can allow us to inspect and see details about the particular stream. So this is how we can look at those and see how it actually, what are the details, how much memory it uses, and things like that. All right. Yeah, one thing that I forgot to mention, all the applications here are using Java, but just as I mentioned, Cloud Events, NATS, and AsyncAPI don't really care about any language. They are completely programming language agnostic, and there are multiple clients in different languages that can work with Cloud Events, that can work with NATS, and which can also work with AsyncAPI. But for this particular presentation, I decided to use Java and Spring Boot. Right. So as I see here in the logs, we can see that metrics data is collected and published, and once the data is published, we can actually go to the we can go to just a second. I should switch the yeah. We can go to this address and find our dashboard. So in this particular case, we have memory usage, and similarly, we can look at the CPU usage. So we'll change it to CPU. Okay, pretty cool. So as you can see, here we have the memory, which is fluctuating from 2 gigs to 4 gigs, and here we have the CPU usage, which is fluctuating from 20% to almost 80%. All this data is randomly generated, and I was just trying to prove that how we can leverage NATS and how NATS can be used for these interactions. And now that we are done with the demo, I wanted to show you a little bit how the code is organized. So as I mentioned, in this fixtures observability platform, we have a couple of services. So we have the first one is our demo app, which actually exposes an endpoint that generates the random data that you saw in the dashboard. Then we have the metrics agent, which actually scrapes the data from the metrics endpoint exposed by demo app. Then we have the data collection service, and then we have the reporting service. The JSON schema visualization and NAS provisioning are just some helper, are some folders that I'm using for the whole setup. What I wanted to show is that every service that interacts with NATS actually has an AsyncAPI document. This AsyncAPI document describes the details like servers, the operations, the channels that we should use. And here, as you can see, we have the channel actually references the address as metrics, and metrics is the stream that we actually use, and I have shown you in the NATS stream info command, and it has all the details. And on this particular service, data collection service actually reads data from NATS. That's why we have an action receive. This is a recent change that has been made in AsyncAPI 3.0, which makes looking at these operations much easier. In the past, we used to have publisher and subscribers, and there was a lot of confusion around that. With the new 3.0, the spec has been changed a little bit, and now we have this explicit action, which lets you know, is this a receive? Then it means that you read data from a particular endpoint or from a particular topic or address. If it's sent, then it means that you publish data or you send data to that particular address. So this is so we have data collection service, which uses action receive on one end, and then we have the metrics agent, which also has an AsyncAPI YAML. And as we can see, we have action send, and it's using the same channel address, which is metrics. Now, the interesting part regarding this async API is that it can reference JSON schemas, and this is what we do here. So the JSON schemas from here can be found in this particular folder. And as I mentioned, we can use async API tools to generate the data that is sent over the wire. So for data collection, for example, we have this tiny script which uses async API Modelina. I mean, all of these details are not that important. The point that I'm trying to make is that we are using the JSON schema that is referenced in async API, and we generate the classes. And the generated classes can be generated class can be found here. So we have the metrics data, and this is an auto-generated file. It wasn't written by hand. It has been auto-generated by this particular script. And this allows us to move fast and to make sure that whatever we have in the JSON schema is compatible with the stuff that we send over the wire, and they are always in sync. All right, that's all that I had regarding the demo. Now going back to the presentation. So